Hello and welcome to another linear programming problem. It's going to be a word problem this time. Hopefully we'll be able to take that from the real world and trying to make sense out of it. But let's go ahead and slowly read the problem and how to also see how to put it into a solver-based problem where we're going to be applying, the linear programming understanding that we have been exposed to so far in order to come up with the best possible solution. Remember, we're talking here about optimization. So this is directly coming from a book by the Decision Support Systems, the third edition, and it's a problem 2-26. A furniture cabinet maker produces two types of cabinets. Okay, so we have two types of cabinets, and that house and hide plasma televisions, TVs. The mission style cabinet. So we have a mission style cabinet. I'm going to immediately start putting not to forget, take notes of mine. And cabinets require 340 in materials and 15 hours in labors. So I'm going to go ahead and also put the fact here, the constraints. I'm going to create the constraints because when we talk about some sort of requirement, that's part of the constraints. So we're going to look at the constraint regarding the material. Okay, before we forget and get lost with all the different details of the problem. And regarding for the mission cabinets, okay, we could go ahead and put mission cabinet also, so we don't get also confused by the word mission by itself. Here we go. Let's go ahead and do it this way even better. This is the constraints. You want to go ahead and make it bigger and even give it a nice underline, so we'll be able to distinguish that from the other constraints. And maybe a column here in material, so not to forget that we have for the mission cabinets, we have material, it's at $340 for the materials, and for the labor it's going to be, here we go, the labor is going to be $14. Okay, so to produce, and it yields a profit of $900 per cabinet. So when we talk about the profits, let's go ahead and put that here, the profit, which is really, this is the objective function. It's going to be, meaning it's going to be the function 3, what do we call it, 910 multiplied by x plus whatever is the y variable, the coefficient for the y variable. So the 910 is the coefficient of the x variable, which is in this case is the mission cabinet. So we're still talking about the mission cabinets. The other style is called the rustic style, and now we're going to be dealing with that. Require $440 to produce in materials, and 20 hours to produce versus 15 hours for the mission cabinets. To ensure, of course, we need to get to the coefficient of the profits for this type of cabinet is 1,220. So this is basically $1,200, $1,200, 1,200. No, I'm sorry, it's 1,200. And this is basically similar to this, like 900x plus, that's the function 1,200y. And x is going to be the mission cabinet, and y is going to be the rustic cabinet in this case. We understand it takes us $340 to produce the mission cabinets. It takes also 15 rather hours to produce. We're talking about the rustic. It's going to take 430 when it comes to the materials, and 20 hours to produce. The profit is in this case called the DMR. There you go. This is also should be money. Yeah, that's going to be, yeah, material is money. and this is number of hours. Let me go ahead and get rid of this so I'll be able to understand how we're going to be able to do it. In those two here, I'm going to go ahead and make them the yellow color because that's what we're going to solve for. But let's get to this later. What we have to do here, the firm has, to continue with this, the firm has a budget of $30,000 to spend on material. So the constraints immediately, it's going to be less than or equal to $30,000. Okay? And usually the constraints, we color them with the blue color, so you could choose whatever color, but just to be consistent, which is also, we call this the right, hand side. And this is going to be the sign, whether it's greater than or less than. And here it's going to be the right hand side, okay? And forgot here additional 0 that could make the difference between a disaster solution or, a optimal solution. Here we go. And to spend on material to ensure full employment, the firm wishes to plan to maximize its profit, but at the same time to keep all 30 workers fully employed. So all 1,200 available hours available must be used. So what is the best combination of furniture to be made? Very clearly, this is 1,200 available labor hours. Must be actually equal to whatever the number of the hour be. Take that out. Must be equal the 15 hours spent on one mission cabinet and 20 hours spent on the Rustic. The combination of the hours in order to manufacture certain elements of cabinets or certain numbers of cabinets and certain number of Rustic. These here where we're going to actually get those the calculation to tell us how many mission cabinets I need to manufacture and how many Rustic cabinets I need to manufacture based on the fact that this is going to give me a profit of $910. This is going to give me a profit of $1,200. This is the coefficient in order to produce the material, in order to produce one cabinet of machine, and this is the coefficient to produce one cabinet of Rustic. But we have a major and clear constraints. All the number of the materials that we're going to be, or the quantity of materials that we're going to be used, it should never cost us more than $30,000. It should be less than or equal, of course. The idea here is to use as much as we can in order to produce as much as the market wants. The same thing here, we have to utilize all the hours because we're paying these people anyway of 1,200 hours. But notice that this is going to be 15 for one of those and 15 hours to produce one of the mission cabinets and 20 hours to produce one of the Rustic. Clearly, we could take actually trial and errors. Let me go ahead and I'll also do this to make it more readable and even do this a little bit better. This is the profit. Let's make it a green color. And notice here the problem to where we're going to be solving for is going to be also green, which is that's what we're going to be doing. So let's go ahead and notice that the profit is going to be the sum products of these two, which is I'm going to lock anyway because I will see why I'm locking it, multiplied by these two. Here we go. Okay, so far is the profit, but we need to be able to also drag this here. I'm going to copy this and put it in here and copy it without paste without just values. We don't want to change the color or anything. Okay, so this is again the corresponding, nope, sorry, it's not a value, it's a formula. So I'm going to go ahead and copy this, and when I paste here those two, it has to be pasted as formula without the formatting. Okay, here we go. So let's go ahead and see if that is being pasted. No, obviously it didn't get pasted. Copy here, and go ahead and select both of those and paste it. Oh, I changed the color anyway. I just wanted to paste it without the I just want to pass the formula. So undo, and I don't want to make this. Maybe we all learn something from this, even if it took our time. Just paste the formula, and let's go ahead and center that so it could be away from it. So this is basically the sum product of these two multiplied by these two. Of course, when the model decide on this number of this and number of this to maximize the profit, which is in this case this one here. Also, we need to make sure the constraints is being calculated as this multiplied by this plus this multiplied by this in order to determine the material, which should be less than or equal to $30,000. Descending, this is multiplied by this. That's why I copied the sum products function to go down. This multiplied by this plus this multiplied by this. And now we could go ahead and do some trial and error. Let's say here I put 100 cabinets here, and let's say here, let's say put 100. Immediately I'm violating so many things because this is way too bigger than this, and this is not equal to this. Okay, and even though the profit seems to be very large, however, that's not really realistic based on our resources that we have very little of comparing to what this is produced. All right, let's go ahead and just make it sure so you could understand. If I put this 5, still actually this is larger than this. And let's say here we put 50, and notice this is going to be small, and this is, they're going to meet the criteria. But we made the profit of 60,000, 64,000 if we produce 5 of this and 50. Of course, it's going to take us probably 1,000 number of iteration, meaning attempts, in order to come up with the optimal solution. So why should we really bother with all this? Well, we have Solver to do the whole thing for us. Let's go ahead and go to data, okay? And I'm going to go to Solver. I wanted to go ahead and remove everything, start it from scratch, so we'll know what we're doing. From scratch, delete and delete, and let's go ahead and see the set of the objective function is right here, which is the profits, where multiply the profit for each item by the number of the items that the model is going to figure out for me. And by changing with cells, by changing these two cells. Now, the constraints. We're going to go ahead and add the first one, which is going to be this one here, the blue one here is going to be less than or equal to the $30,000. And add. Let's go ahead and do this. It's going to be equal to, because remember, we must spend all the hours for the labors, which is 1,200. And let's go ahead and okay, because this is the last addition. So once we finish our constraints, we say go ahead and okay. And now we have both of them, all right? So the left hand side and, of course, right hand side has been completed. Make and constrain variable non-variables. We wanted to have the number of the cabinets and the number of the rustic cabinets to be, of course, 0 or more. We don't want to have -5 physical entity like table. That would be crazy. And we have also the simplex linear programming. And let's go ahead and hit enter key. Obviously, it found a solution for us. And we're going to say, okay, wonderful. There is no way that we had to live without the fact that this must be equal to this. So the criteria absolutely was met. This is also the criteria has been met because it was less than or equal to $30,000. This is our maximum profit based on what we found here. And in this case, in order to do the best possible solution, believe it or not, the answer is to focus completely on the production of machine cabinets and ignore the rustic cabinet where 0 is. 0 would be the best option to do this. So maybe in the long run, based on this style of the problem, we have to be geared toward like switching from rustic to machine more and more until completely we get rid of the rustic and focus on the second one where the profit is going to be better. I hope this has taught you something. There is nothing can be learned unless you get your hand dirty, and in order to come up with, a better understanding. Okay, so let's go ahead and do that on our own a couple times. Check all this calculation, make a mistake here and there. All this confusion of where things coming from cannot be learned unless you really practice with it. And remember, some products function is always there to rescue, so it will save you a lot of time instead of trying to really do simple calculation like traditionally. So functions like some products is very helpful, and also the solver it's going to get better than that in order to come up with the optimal solution without having to spend hours and hours trying to figure out what would be the best solution based on your trials and error. Thank you and have a great day.